Oh, hi there. Hi, I'm NASA astronaut Nick Hague, living and working aboard the International Space Station. Stability in spacecraft is important. It's what keeps satellites and space telescopes oriented in the right direction to make observations and send data back down to the ground. Here on the International Space Station, stability keeps the bottom of the station pointed toward the Earth and our solar panels pointed toward the sun so we can charge up and we have power. Let's face it, none of us want to spend our entire time on orbit feeling like we're on a gigantic carnival ride, constantly tumbling around. Though I gotta say, it's fun to do every now and then. Never gets old. But we have to stay stable somehow. Although the space station is equipped with thrusters to give us little nudges here and there, they require fuel, and that's not very efficient. A more efficient way to keep us pointed in the right direction is through using rotational stability from gyroscopes. Today, we're going to explore rotational stability and how gyroscopes can be used to keep objects pointed where we want them. Every object has its mass distributed in different ways. How the mass of an object is spread out affects how it rotates around each of its three principal axes. For example, spinning an object around its minor axis, where its mass is closest to its axis of rotation, is stable. This is what keeps a spiraling football stable as it flies. Rotating an object around its major axis, where its mass is concentrated around the perimeter, is also stable. This is what keeps a spinning top upright and a frisbee stable in flight. Finally, if you spin an object around the third axis, called its intermediate axis, it will be unstable. Even the slightest amount of imbalance will cause it to flip or tumble. This is called the intermediate axis theorem. When an object like a T-handle or a wing nut is spun on its intermediate axis and then allowed to move freely in the microgravity environment of space, at first it appears stable, but as the instability in its axis of rotation increases, there's a sudden shift in its inertia, snapping it around 180 degrees, where the process begins all over again. While this might look cool, it is not something we would want to have happen on a spacecraft. To keep spacecraft stable, we use gyroscopes. A gyroscope is a spinning wheel with its mass concentrated far from its axis of rotation. As they spin, they resist rotation along any axis other than their spin axis. The International Space Station has 4 different control moment gyroscopes, or CMGs. They consist of steel wheels at different orientations that spin at a constant speed of 6,600 revolutions per minute. Not only do the CMGs keep the station stable, but we can also reposition them to induce a gyroscopic force to change the orientation of the station. Here I have a simple model of a gyrostat, or a device used to test gyroscopic control. It's very easy to make and consists of a gyroscope placed in the middle of sheets of cardboard. As you can see, we've colored 1/2 of each side so that it helps us keep track of the orientation of the gyrostat. And so there it's spinning around its minor axis and it's stable. Nice and stable around its major axis. Now I'm going to set it up so that I spin it around its intermediate axis. This is the one that goes through here. And there you can see it tumbles around another axis as it rotates. No matter how hard I try to get it to only spin around one axis. Now let's see if we can make the gyrostat spin with stability by spinning up the gyroscope. axis of the spinning gyroscope in the same direction as the rotation of the intermediate axis, the gyrostat, it's now stable. Even as irregular as a camera, you can try to find where its axis, major, minor, and intermediate axis are. This looks pretty stable. No twist there. And if I'm right, it's going to turn around and the camera is going to point toward you here shortly. Then it's going to turn around and point toward me. And it just keeps repeating. So every object's got it. I hope you enjoyed this demonstration and learned a little something new about rotational dynamics and gyroscopic stability. Now, you go give it a try. Make your own gyrostat, just like mine. Thanks for joining me here on the International Space Station.